going to talk about translations. There's some properties of translations we want to understand. And another word for translation is slides. So there is no real easy, clean definition for translation. I'll do the best I can to describe it. I'm going to pause this so I can write easier. So while you're writing, I'll read through this, make sure you read my writing. Translation maps an image onto a pre-image so that the orientation is the same. Again, it's not a great definition because that's also true for rotations, which we'll talk about tomorrow. All right. A composite is a combination of reflections, so more than one reflection. Most of what we're doing will be two, sometimes it'll be three. And then when that composite is over parallel lines, the result is a translation. So if I draw a couple lines here, and I just put a point, oops, sorry. I put a point here, we'll label it A. If we reflect A over line L, I get we'll pretend that. Is it pretty close?
Sure.
Okay. And then if I reflect A over M, I get something like this. And so this would be the first reflection, this would be the second reflection, and we use one tick mark, we call it A prime. If we use two tick marks, we call it A double prime. Okay? Now, if I just do some, I'm just going to go real. Make this more than a single point. And this would be here. And then this one would be here. Now you can see the orientation that I was talking about before is the same. If I go A, B, C, it's which direction? Clockwise or counterclockwise? Counterclockwise. My first reflection flipped it over, didn't it? Yeah. Then when I reflected that one again, it went back to the normal. Okay? So every time you reflect it, it's going to reverse the orientation. So if you reflect it twice, it's going to reverse it twice. You'll be back to where you started. Okay? So the translation, the orientation is the same. And if I took this figure, that is pretty scary how close that is, since I just did it freehand. But you'll see what I'm trying to show is that by taking this figure over here, from here, I just slid it over. It's just a slide. It's no different than when you were in elementary school and you went down the slide on the playground. You were sitting up at the top, and you stay sitting up all the way down when you get to the bottom. The only difference is you're in a different place in space. Okay, your body's still in the same position, and you end in the same position. Not quite true when you go to the water park at Cedar Point. The guys all getting up, pulling their suit out of their behind, and everything gets turned around. You ever watched any of those funniest on YouTube every once in a while, I'll watch some of those. People videotaping people who have gone down water slides. And they get up and they're always rearranging their suit, and they're always, their body's out of whack. And so, all right. I guess that's just me.
You just jumbled the whole thing right there too.
What's that?
You jumbled the whole thing.
Yeah, I know. So again, this is just a slide. The result is I took this figure that was here and I slid it over to there. Okay? Now, here's something that's a little different. If this distance between these two lines was, say, 5 inches. By the way, to measure the distance, it'd have to be perpendicular lines. Then that means the distance between these 2 points, that's scary also, they're all on the same line, is going to be 10 inches. Okay? It's going to be 10 inches. So however far apart the lines are, the translation, the result of the translation is going to be twice as far. Okay? It's going to be twice as far. So let's go to here. We'll call it, I'm going to pause again. So again, the first one's a repeat, orientation's the same. The second one is what I just said. The distance of the slide is 2 times the distance between the lines. And then there's another one, we'll talk about it, it's called the direction. So the direction, let me pause. This little symbol right here is a composite symbol. I didn't draw it very neatly, it's just a little circle. Okay? In fact, we'll just replace that. That looks better. That composite symbol means that this is how I'd read it. The reflection over M of the reflection over L. And so when I reflected this, I went over L first and then I went over M. So my reflection was this direction, right? So it went from L to M. And so it went in the direction from L to M. Does that make sense? So the result is my L was on the left, M was on the right. I went from L to M. So my result is I slide this to the right 10 inches. Okay? I'm going to slide it to the right 10 inches. That's going to be the direction of my slide. And so it's always in the same direction as the reflections. Okay?
But why is it written like...
It's written backwards because this is like parentheses, this here. That's like using parentheses. It's saying the reflection over M of the reflection over L. And you always do what's in parentheses first, right? And so we never write it this way. It really isn't written this way, but I'm trying to make you understand that's what it's kind of like. And so this is telling us to do this reflection first. So we have to do the reflection to the right, furthest to the right reflection first. And we read that composite symbol with the word of. And so it's a reflection over M of the reflection over L. So we had to reflect over L first, take that answer, reflect it over M. Okay? All right. And so anyway, the result is going to be a slide. It's going to be twice as far as the lines are apart, and it's going to be in the same direction as the reflection. Okay? And so the direction is the same example. If I do reflection of M of the reflection over L, then my direction will be L to M. Okay? The reflection then will be from L to M. I wanted you to understand about the lines, even though in the assignment we're not doing a lot with lines. Okay? They're going to use vectors. Okay, so let me show you now how easy it is to translate using vectors in coordinate planes. Okay? So if you think back to when we covered vectors, we said the vector coordinates 2, 5. Remember, the V-shaped parenthesis is intentional. That means vector. Okay? On the coordinate plane, would be would be that vector right there. Starting at the origin and ending at the ordered pair 2, 5. Okay? That is our vector 2, 5. Now, if I have this sorry, take me a second here. If I have this triangle, okay, and we'll call it ABC, and I want to translate this triangle ABC using this vector, then what that means is I want to move every one of these points two units to the right and 3 units up. Okay? I want to take every one of them, move them 2 units to the right and 3 units up. So that puts, come on. That puts my triangle up here, and every one of these points, C was moved 2 to the right, 5 up. B was moved 2 to the right, 5 up. A was moved 2 to the right, 5 up. Okay? And so this is A prime. This is B prime. And this is C prime. Okay? That's all you have to do when they ask you to translate on the coordinate plane. And they give you a vector, the vector coordinates 2, 5. That means you're going to move every point 2 to the right and up 5. Now, what if they'd given me 2, negative 5? I'd go 2 to the right and 5 down. So that means instead, this would go 2 to the right and 5 down. So it's 1, 2, 3, 4, 5. It'd end up there. 2 to the right, 5 down. Okay? So very easy to move on the coordinate plane. Okay? And that's what they're asking you to do in most of the homework. So today, for your homework, let's just do the odds through 29. You should have lots of time. Most of these won't take long. Lesson 12 to 1 through 29. Odd.